In this question, we have a sample space which has events E1 up to E10. And we have been given A complement as E1, E3, E7, E9 and B complement as E2, E3, E8 and E9. And the first thing which we have to find is the intersection of A and B. If we can look at the graph here, we can see what is A intersection B. A intersection B is basically going to consist of all the common elements which are a part of both A and B. So all the outcomes which are a part of A and which are also a part of B will go into A intersection B. This is how we represent A intersection B. But before finding A intersection B, first we need to find the event A and event B, because in the question we have been given A complement. Now what is the definition of A complement? A complement means all those elements in the sample space which are not a part of the event A. So if I want to find A from A complement, I will have to look at all the outcomes which are a part of the sample space but which are not in A complement, right? So A complement consists of E1, E3, E7 and E8. So basically A will consist of all the outcomes of the sample space other than E1, E3, E7 and E9. So let's see what will be those outcomes. So E1 will not be there, we'll get E2, E3 will not be there, we'll get E4, then E5, then E6, again E7 will not be there. So we'll get E8, E9 will not be there and we get E10. So this is how we can define the event A. Similarly, here we have been given B complement and not B. So first we have to find B. What are the outcomes which will be a part of B? Basically all the outcomes which are a part of the sample space but are not a part of B complement. So other than these 4 outcomes that we have, all the other outcomes of the sample space will go into B. So here we are going to have E1, then E2 will not be there, E3 will not come, E4, E5, E6, E7, then E8 will not be there because it's there in B complement. E9 will not be there, that is also there in B complement. And lastly, we have E10, right? So now we have the event A and event B, and now we can find out A intersection B. What will be A intersection B? A intersection B is going to consist of all the outcomes which are also a part of A and which are also a part of B. So for example, E1. E1 is only there in B, it is not there in A. So E1 will not be a part of A intersection B. What about E2? E2 is in A but not in B. So again, it will not come into A intersection B. What about E4? So now E4 is a common outcome. It is a part of A and a part of B. Similarly, E5 is a part of both. E6 is also a part of both. E7 is in B but not in A. E8 is in A but not in B. E10 is again in both A and B. So therefore E10. So this is how we can find A intersection B. A intersection B is equal to E4, E5, E6 and E10. Now the next part of the question says that we have to find the union of A and B. The union of A and B, if we can look at the graph here, union means that all the outcomes which are either a part of A or a part of B are going to form a part of A union B as well. And the way we write it is A union B. So basically an element can be a part of A, it can be a part of B, or it can be a part of both A and B. But whatever common elements we have or whatever common outcomes we have, we are only going to write them once, right? So that is what we are going to keep in mind, that the common outcomes will be written only once in A union B. So we have already worked out the event A and event B. Let's try to work out A union B. Now, A union B will consist of all the outcomes which are either a part of A or a part of B or a part of both. So let's start with E1. So E1 is a part of B, so it's here. E2 is a part of A, so it will form a part of A union B. Now E3 is neither in A nor in B, so E3 doesn't come here. E4 is a part of both, but we are only going to write it once. E5 is also a part of both, we are going to write it once. E6 is a part of both, we are going to write it once. E7 is in B, E8 is in A, E9 is in neither, so we don't have it in A union B. And lastly, we have E10, which is in both, so we are going to write it once. So now A union B has the outcomes E1, E2, E4, E5, E6, E7, E8, and E10. The last and the final part of the question asks us that is the union of A and B collectively exhaustive? What do we mean by collectively exhaustive? Collectively exhaustive in simple words means that when we take the union of two or more events, whether all the outcomes in that union are there in the sample space also. So basically, if the union of these events contains all the elements which are present in the sample space, then we can say that yes, the union of these events is collectively exhaustive. So here we can see if we can compare this A union B to the sample space that we have. So we can see that yes, E1 is there from the sample space, first element, E2 is there, but do we have E3 in A union B? No, we don't have E3. Then we have E4, E5, E6, E7, E8, but again, we don't have E9, and then we have E10. So since A union B does not consist of all the outcomes of the sample space S, therefore we can say that no, A union B is not collectively exhaustive, right? A union B is not collectively exhaustive.